Hi, this is Lori, and this is my homework for Paul McWhorter's course, AI on the Edge. I'm working on the homework from Lesson 12. The homework that Paul assigned was to use voice commands to control the brightness of the red channel of the RGB LED. Now, I think he meant for us to be able to use threading with this assignment, but this assignment doesn't require threading. So I didn't focus on that. I focused on instead being able to capture the numbers people spoke and converting them to digits that we could then use to set the brightness of our RGB LED. And I'll do a part 2 where I instead use the blink rate homework that we had done previously, because that one does require threading to make it work, so that I can be faithful to the intent of the homework. All right, let's take a look at what I did for controlling the brightness of the LED. So I started off just trying to see how numbers are going to come across using the speech-to-text model. So I simply had a very simple program and just spoke some numbers in and saw how they get translated. So for example, 62, 71, 93, and like when you say 100, what's going to happen, 0, so forth. So just to get an idea how to get started thinking about translating this text into digits that we can use to set the brightness. All right, so let's look at the code that I put together. And so I'll set up the speech-to-text object and the RGB LED as we have been doing. And I did this first and then took a look at other people's solutions. I know Paul decided not to deal with the numbers at all. He came up with levels of brightness using words. But I think it's a nice challenge to actually try to convert the words into numbers. I think that, to me, that was the challenge of this assignment, since we weren't really needing to do threading. And the dictionary you need, if you're going to say you can only say whole numbers between 0 and 100, is actually pretty small. It's not very large. And I won't allow any decimal places or anything like that. So you have to say a whole number, or it's going to keep re-asking you to input the brightness or say the brightness that you want. So that, at first I thought that was going to be pretty large when I first thought about this, but then when I started putting it together, I was like, oh, it's actually pretty limited how many things you need to put into this dictionary. All right, now we'll go into the main loop here. And I'll talk about this flag in a minute. Whoops, went too far. A little laggy today. There we go. I'll talk about this flag in a minute. But we're resetting a flag that we're going to use later in the code back to false. So we'll ask the user for the brightness level they want. And also they can say stop in the program. And so we'll just break out and make sure the RGB LED is off. And I'm doing a lot of printing here just so you can see what's happening in different parts of the program. Obviously they're not necessary, but I think it's nice for learning to see what's happening at each point in the program. And then we're just going to split up the command into the words, print that out, and we'll count up how many words we have. And if you have more than 2 words, then you've said something that's outside of 0 to 100, or you've said something and you didn't mean to send a command or whatever, but it can't possibly be something we can use for brightness if you say more than 2 words. So you get a chance to try again. Let's see if I can get up a little bit more here. All right. So to hold the numbers that we're going to need to match up with the words, I create a little list called digits, and then we're going to loop through the words and find the digits that correspond to those words in our numbers dictionary. And if we don't find something in the dictionary, then we're going to say, well, you said something that's not possible, and so we're going to tell them to try again. And this is where the flag comes in. I'm just going to say flag equals true because I don't want it to continue processing this data. I want it to just go right back up to the top of the loop and ask them to try again. So it breaks out of this for loop, but then it goes back up to the top and tries again. And that's why flag needs to be turned false as you come to the top of the loop. Now, if you did speak something that can be translated from our numbers dictionary, if the flag is not equal to true, then we got something good, and we'll go ahead and process it. So we'll sum up the digits, list. And then if it's over 101, I mean, somebody could say something in 2 words that is more than 100, like 50, 60 or something like that. So if they try to do something like that to make my program break, well, it won't work. It will tell them that you entered something that isn't going to work. Okay, so they get a chance to try again. And if you say 100, the way my program's working, it'll sum to 101, and so that's fine. We'll just say the brightness is 100. I guess we could have caught that with some other kinds of if statements or whatever, but whatever, I thought this was fine. And then when you say 0, because I want to use my nonlinear dimming equation, then I don't want it to process this, because I don't want 0 here at the top of this fraction. So I'll just set the nonlinear percent to 0 so that it's fully off. And otherwise, we're going to use the nonlinear equation that I've used in the other homeworks. We'll print that brightness out and set the RGB LED to that brightness. And we'll do the keyboard interrupt to potentially close out as well. So you can quit by saying stop, but you could also quit by saying Control-C, and both will work. And, the reason why you don't need threading is because once you set the brightness of an LED, there's no code that needs to maintain that brightness. So it just stays at that brightness until somebody changes it, which is why the threading is just not necessary for this homework. I know Paul went ahead and handled it with threading because he wanted us to understand that, but not necessary in this case, and I couldn't stop my mind from saying I can't do it that way because it doesn't make any sense. So that's why I did a second homework where it was required. All right, so enough talking about that. Let's run this. $25, $50, $75, $100, $0, $10, stop. All right, so I think it works great. And it was neat to figure out a reasonable way to translate text into numbers just on your own for something simple like this. Now let's do a homework where we really need threading and voice commands together. All right, so this will be my homework to demonstrate the use of voice commands with threading. I think using the blink rate homework that we previously did, where we took the input from the user directly from the shell, them typing in the blink rate they want. Instead, I'm going to have them give me the blink rate via voice command. And so now I have to probably handle some decimal points because you often want to blink at like 0.5 or 0.1. So I'm going to add that in, but I am going to limit it to between 0 and 10 seconds. I just and also you can't, in this program, you can't say anything beyond 1 decimal point, just to put some boundaries on this. Make it not a lifetime project to make it work. All right, so yeah, here we go. So this is the program. We're going to import all the necessary things and set up our speech-to-text object. Then we'll set up our LED, and we'll set the blink rate initially at 0, so we won't blink until we get some instruction on what blink rate the person wants. And again, I'm just using the threading library only, and using thread, lock, and events to lock to pass the data back and forth, and events to signal when to end thread and when to signal that the blink rate has changed. So that seemed to work pretty well in this context. I'll dig into the Q library at another time, I guess, because this seems to be working in my homework. All right, so we have to create the two events, and I talked about this in my previous homework, so I won't spend a lot of time on it, but one of them I'll use to end the blink thread, and the other one I'll use to indicate that there has been a change in the blink rate. Now, the numbers that I need are actually less, because I'm saying you can't say anything over 10 seconds. So this is my dictionary, and I had to add in point, because people will say 0.1 or 0.5 or 0.5. They can say any of those things to enter a blink rate. And you'll notice that now, instead of having the dictionary values be actual numbers, there's text. And that's because we got to deal now with points. And so the way I did it for the previous part of the homework isn't going to work anymore, because the point doesn't have any value, so you can't do that. You're going to have to work as text, concatenate everything together, and then convert it to a float. So that's the idea. So that's all there really is to putting this together. All right, so my blink function is the same as it was in my previous homework, and the blink thread, everything is pretty similar. We'll just go on down here. It's actually kind of simpler in a lot of ways. So we'll get our command, we'll split it up into words. If the person says stop, then we'll try to gracefully exit from the program. We'll indicate an event rate happening, even though the blink rate isn't changing. We want to interrupt the blinking, and that the event rate does that. It interrupts the blinking. And then we'll say, signal to the blink thread, it's time to end. We'll give it just a little bit of time to do that, and then make sure the LED is off and break out. All right, so there's some checks in here. We'll look to see, are all your words that are in the command split list, are they in the dictionary? If they're not, then your command wasn't understood. If they're more than 3 words, then you said something that wasn't in the right range, or you said something not understandable, so it'll boot you back to trying again. Otherwise, then we probably have a pretty good blink rate value, and so let's process it so we can turn it into a number. And so that's what all this code does here. So it just goes through and just concatenates together the text that it's finding in the numbers directory, and we can print that out. Then we're going to acquire the lock so we can change the event rate, and the blink rate will now just be the float of the blink rate that we concatenated all together from the text. We'll print that out again just to check and make sure everything worked. We'll say that there's a change to the event rate, the blink rate. So many rates. Anyways, the blink rate will release the lock, print the current blink rate, and this indented print here is to say that the main program is ending. And then you can also end using the keyboard interrupt, and it'll print a different. If you do it that way, you'll get a different message as it ends. Pretty similar to what I had before when we took it from the shell, but just allowing the voice commands to work. So hopefully it's going to work for me. Let's kick it off. Point 5. How's that filming? Oh, good. 1. 9. Point 1. Stop. All right, so you can see that even when I asked for 9 seconds, and then I said I don't want to wait on 9 seconds, the event rate was able to interrupt the blinking. And as I said in my previous homework, I'll just go back to that because it's really critical. You can't use sleep It's a non-interruptible function in Python, so you have to use this wait method that is associated with your event called event rate. So that's how you can interrupt and immediately change the blinking rate rather than trying to use sleep. Well, that was my homework that demonstrated I can do threading and voice commands together. And thank you, Paul, for this great lesson. It's been teaching me some new things in Python that I haven't done before. Really enjoying learning a little bit more about threading. And I want to thank you for watching.